Okay, today's lecture is about a package named GDINA in R uh, that actually this package is for conducting CDM analysis within the GDINA model framework developed by Ma and De La Torre 2020. This package actually provides a framework for a series of cognitively diagnostic analysis for dichotomous and polytomous responses. In this session, I'm going to actually following the previous sessions, which were about using CDA package, CDM package for doing cognitive diagnosis. For a better cognitive diagnostic modeling with a variety of modeling, CDM modeling techniques and rules, we can use the GDINA package. Actually, the GDINA package provides you with models like DINA and the DINO that we were actually using to analyze the fraction subtraction data with the CDM package. But also we can feed another models for dichotomous models. Actually, we can use some models, some additional models like the, in addition to DINA, DINO, and the GDINA model that is named for, it's the name for this package. Models like the ARA model, the ACDM model, like that, and moreover, as I said, the GDINA model can also fit it to the data. So in this case, for the fraction subtraction data, as we have no missing values, we can actually feed three CDM model rules like DINA, DINO, and GDINA. The DINA for non-compensatory model, and DINO and GDINA for a compensatory model. Actually, the GDINA is a saturated compensatory model. So in this case, we just run the model one. Actually, in the GDINA, the GDINA function in the library called GDINA. We have this help menu in RStudio, which help you to fit some kind of models that uh, are helpful for doing cognitive diagnosis analysis. In our case, with the actually GDINA function in the generalized DINA model framework, we can actually run a variety of models, as you can see for dichotomous and polytomous item response data, the DINA, as the as we did in CDM package. We can also run models like GDINA, ACDM, LLM, RRAM, MSDINA, BugDINO, SISM, and UDF. You can also run models like LogicDINA and LogGDINA, indicating some kind of saturated GDINA model in logic and locally functions. So for our case, with the GDINA function, we can, in this case, we just apply the GDINA, DINA, and DINO model for the fraction and subtraction data. We can also apply the ACDM, LLM, and RRAM model for dichotomous items, which not includes actually which the missing data is not included in the data set, as we have missing data here that's not named as NA in the data set. The ACDM, LLM, and RRAM models cannot be fitted to these data sets because of the non-named missing data as NA. So we, for the sake of showing you how to do the cognitive diagnostic modeling, we run 3 models named DINA for the model 1, the non-compensatory model, the DINO model we have for the compensatory model, and we have a saturated model that is also compensatory model called GDINA for these kind of data sets. So for our first model, as we use the GDINA package, we also do the analysis through a function named GDINA, similar to the name of the package. The data is actually, we actually named the first model the mod 1. The data set is actually the fraction subtraction data set. You need also actually call the CDM function from library command. So if you actually do run the library CDM command, you have access to fraction subtraction data like this. So I use the fraction subtraction data. Q is in this function Q is for the Q matrix, and the Q matrix is also from the CDM function, as you can see here. The Q matrix, the fraction subtraction Q matrix, as we explained before in our previous video about using CDM package of R to do the cognitive diagnosis modeling. The Q matrix is actually for the fraction subtraction Q matrix. And the first model is actually the GDINA model. So our syntax for running the first model in the GDINA package via the GDINA function of that package is actually the GDINA model. So if we run this model through 124 iterations, the model converts successfully. And then you can run the second model. The second model is actually the GDINA model that is a compensatory model, as we did run it in the CDM package. So the second model is the GDINA model. If you run it with a few iterations, the model converts. So for the third model, for the third and the new model, as called the GDINA model, we change the model to the GDINA model with the same arguments in this command. As you run this, for actually, let me name it the model 3. As you run the model through more iterations actually than the other models, through 220 iteration, the model coverage, because the model is saturated, you have more iterations, actually the more iterations needed for the model to be converged successfully here. But as I said, the process of modeling, since the process of modeling is like finding the best fitting model, as we do in item response modeling and other kind of, for example, structure equation modeling or confirmatory factor analysis modeling. In the cognitive diagnosis modeling, we need also to find the best fitting model. So we should compare the goodness of fit of the models. For example, in this case, we ran 3 models. The model 1 for the GDINA model as the non-compensatory model, and the second and third model is non-compensatory models, GDINA for a compensatory model, and GDINA for a saturated compensatory model. So if you employ the ANOVA function as a basic function from the package stats, if you compare these 3 models, actually the model 1 and the mode 2 for the GDINA model, and the mode 3 for the GDINA model. These functions, if you run this function, there are relative fit functions called AIC, BIC, CAIC, and CA PIC that the lower the indices, the better the model. So you can see for these three models that the model one, that is actually is the GDINA model. GDINA model. You can see that this model has lower fit indices compared with other models. The model 2 is the GDINA model, is the DINO model, the compensatory model, and the third model is actually the GDINA model, the saturated model. And at this process of modeling, cognitive diagnosis modeling, the relative fit indices shows that the GDINA model as a non-compensatory model is better fitted to this item response data, actually for the fraction subtraction data. There are also some inferential statistics as the chi-square with corresponding degrees of freedom that shows that the first model, the GDINA model, with more than 99% of confidence is actually better fitted compared to other models. So we can conclude that the non-compensatory GDINA model is better fitted to this data set. Is actually a math data set, and it is also expected the math skills that needed for answering the item response, answering the test items correctly is not negotiable. So there are some deterministic skills required for answering the math test items correctly. The way that items and skills and profiles actually interpreted is the same for the for this packet. So we skip interpreting the GDINA model because we just did interpret the GDINA model in the previous video. Okay, good for today. Bye.